So mathematical induction method. Okay, so example 12, use the principle of mathematical induction to prove for all n belongs to n that 10 power 2n minus 1 plus 1 is divisible by 11. Okay, so what is given here? So let I am taking the t of n is equals to 10 to the power 2n minus 1 plus 1. Okay, so now, so let I am taking it is divisible by 11. So the numbers, whatever the numbers divisible by 11, what numbers are divisible by 11? 11, 22, 33 and 44. Okay, 55. All these numbers are divisible by 11. How these numbers are divisible by number? Why these numbers only divisible by 11? Because these numbers we can write it as 11 into 1, 11 into 2. Okay, so 11 into 3. Like this we can write all these numbers, means 11 into some multiple, some number. Whenever it is possible to write, okay, any number in the form of 11 into m, 11 into s, 11 into q, 11 into p, 11 into a, 11 into b, like that, some multiple of 11, then it is divisible by 11. It is divisible by 11. Okay, so now so t of n I am taking as 10 power 2n minus 1. Okay, and plus 1. So let I am taking, let t of n is true for n is equal to 1, or t of 1 is true. If it is true, then substitute. Okay, so t of 1 is equals to 10 to the power 2 into n means 1 minus 1 plus 1. This is equals to 10 power 2 1 is a 2 minus 1 is 1 plus 1. 10 plus 1. What is 10 plus 1? 11. Okay, so is it divisible by 11? Yes, 11 we can write it as 11 into 1. 11 is multiple of 11. Yes, it is divisible. It is divisible also. Okay, therefore t of 1 is true. T of 1 is true. Or we can write it as t of n is divisible by 11. Okay, so t of n is true or divisible by 11 for n is equal to 1. Divisible by 11 for n is equal to 1. For n is equal to 1, it is divisible by 11. Okay, so 1 is completed. Now assume that. Okay, so this is part 1. Okay, and the next important step is assume that t of k is true. T of k is true, or we can write it as t of n is true for n is equal to k. Both are same only. So if we take t of k, what is t of k? In place of n, substitute k. So that is nothing but 10 to the power 2k minus 1 plus 1. If it is divisible, compulsory. Okay, 11 into some number. I am taking 11 into m. 11 into m. Okay, so take this given equation as 1, and okay, so I'm writing once again. T of k is equals to 10 to the power 2k minus 1 plus 1. 2k minus 1 plus 1 is equals to 11 into m. 11 into m. Just keep it like that. So now we have to prove that. Now we have to prove that t of k plus 1 is true. T of k plus 1 is true. Based on this, by using this, we have to prove that. Okay, so it is also true for k plus 1. N is equal to k plus 1. Now take the t of k plus 1. In place of n, substitute k plus 1. 10 power 2 n. N means k plus 1. Okay. Minus 1 and plus 1. What is the n here? N replace with k plus 1. Replacing n with k plus 1. Now this is equals to 10 to the power 2 into k, that is 2k plus 2 ones are 2 and minus 1 and plus 1. This is equal to 10 to the power 2k. 2 minus 1 is 1. Okay. That means we get plus 1. We get plus 1. Or otherwise do one thing. Okay. So we can do like this. We can write this. Okay. So I am interchanging this. Okay. Minus 1 writing left side, plus 2 I am writing in the right side. Okay. So if you write like that, if you interchange like that, then we get to 10 power 2k minus 1 and plus 2, and this plus 1 is as is. Okay. So now 10 power 2k minus 1 into 10 square I am writing. That means, okay, so what is the formula here? The basic formula here, a to the power m into a power n, or a to the power m plus n, we can write it as a to the power m into a to the power n. Usually, mostly, okay, most of the times we write in the reverse. Okay, we apply in the reverse. A power m into a power n means a power m plus n. So, but we in this case we are okay. So applying in the reverse. So a power m plus n is equals to a power m into a power n. Whenever we have addition in the middle, okay, so we can write the same base for both the powers. I did the same thing here. 10 power 2k minus 1. Okay, with the same base I written, okay, 2 also. Okay, now this is equals to, why I am writing like this? 10 power 2k minus 1. Okay, from here 10 to the power 2k minus 1, we can write it as 11m minus 1. Take it as equation number 2 and substitute this value here. Okay, so that means 11m minus 1 I am writing in place of 10 power 2k minus 1, and 10 square is 100 and plus 1 is as it is. Plus 1 is as it is. Okay, so how we got this? This is from equation number 2. We substituted equation 2 here. Now multiply inside. Okay, now multiply inside. Okay, 100 into 11m. 100 into 11m. Okay, so 11m into 100. I am multiplying. Okay, so minus we have 100 into minus 1. Okay, minus 1 into 100 minus 100, and plus 1 we have. Write this plus 1 as it is. Write this plus 1 as it is. Understood? Okay. So now in this I am writing this 11m into 100 as it is, or otherwise we can write 1100m also. Minus 100 plus 1 is minus 99. Minus 99. Once observe carefully, can we take the 11 common in this? Yes, we can take 11 common. Okay. So if we take 11 common, so then 11 into 100m minus 11 9 times is 99. Okay. So 11 into already we took m. So here I am taking n. So how we got this n? So let I am taking some multiple. Either we can take okay, m or n or p, q, a, b, any value. Okay. So let I am taking n is equals to 100m minus n. 100m minus n. Okay. So that is nothing but, is it in the form of multiple or not? Yes, it is in the form of multiple. Therefore, t of k plus 1 is also true. Or we can write it as t of n is also divisible by 11 for n is equal to k plus 1. N is equal to k plus 1. Therefore, by the principle of mathematical induction method, Hence, by the principle of mathematical induction method. Mathematical induction method what we have here, 10 power 2k minus 1, 10 power 2n minus 1 plus 1, 10 to the power 2n minus 1 plus 1. Okay, this is the function here. Is divisible by 11 for all n belongs to n, for all the natural numbers, n, small n. Okay, so belongs to capital N, means for all the natural numbers, Okay, understood? Do you have any doubts still here?
No, sir.
Okay, good. For more educational videos on ISC, CBSE, Intermediate, as well as IIT-JEE, BITSAT, EAMCET, please like, share, subscribe our VEDHA online classes. Thank you for watching. Have a great preparation.